So let's move on now. Let's talk about common factors. Common factors are a number with which a set of two or more numbers will be divided exactly. So this is something we use when we're comparing two different numbers and looking at their factors. Right? So the process of this is to write the factors of the given numbers and then find the common factors present in them. So for example, if we were looking at the numbers 12 and 18, you could write down the factors of each of those. So here's factor bugs for each of those. We have 12 here and 18. Yes, one of them has eyes and one of them does not. Don't ask me why. But here are the factors of 12, right? We have 1 times 12 gives you 12. 2 times 6 gives you 12. And 3 times 4 gives you 12. For 18, we have 1 and 18. 2 times 9 and 3 times 6, right? So the common factors we get once we've written down the factors for each of these, right? And we can see that 1, 2, and 3 are common amongst the two. And there's another one, 6, right? 1, 2, 3, and 6. But 4, 9, 18, and 12 are not common. So you write down all the factors, you look and see which ones are on both factor bug or both sets of factors. Those are the common factors, right? So we can try a bit more difficult one. What are the common factors between 64 and 48? Yesterday in our lesson we found the factors of 64. Hopefully you have that written down somewhere. So 1, 2, 4, 8, 16, 32, and 64. So now you're going to need to find all the factors of 48. So I'm going to give you a little bit of time. I want you to do that, and then I want you to write down all of the common factors between these two. So pause the video, take a second to do that. So let's do the factors of 48. The very first one, hopefully you know this one right off the bat, is 1 times 48 will give you 48, right? 1 and 48. And again, this eliminates a bunch of numbers, right? Anything bigger than 48 and anything smaller than 1 is not going to be a factor. We've eliminated all those. The second one, this is an even number, right? So 2 will divide it evenly. 2 times 24 is our next factor pair. And again, this has eliminated a bunch of other potential numbers, right? So there's none of these numbers between these two will be factors anymore. 3 also divides into 48 evenly. It goes in there 16 times, right? So these appear on our line. Again, we've eliminated a bunch of other numbers now. We know 17 through 23 are not factors. 4 also goes into 48 12 times, right? We're eliminating more numbers that are potential factors. 5 is not possible because this does not end in a 5 or a 0. 6 goes into 48 8 times, right? So now the only number left that's possible would be 7 because that's the only number between this factor pair, and 7 is not possible, right? So we have found all of the factors of 48. We found these yesterday. Now you can compare which numbers appear on both lists, right? So you can see 1, 2, not 3, 4, yes, not 6, 8, yes, not 12, 16, not 32, not 48, not 64. So the common factors would be 1, 2, 4, 8, and 16, right? So the process to this is pretty straightforward. You just have to make sure you're finding all the right factors. And now we know when to stop looking, right? We got to our last factor pair. There was one number in between it. We tried it. It was not possible. So now let's think about the highest common factor. Right, so this is just kind of an extension of that original principle. We're looking for common factors, and we're looking for the biggest one possible, right? So the highest common factor of two numbers is the highest factor that can divide the two numbers evenly. So our process, again, is write a list of all the factors and then identify the highest one that's in both lists. So here's those factor bugs again, right? For 18 and 12, we know the common factors are 1, 2, 3, and 6. And 6 is the biggest number of those common factors, right? So this is just adding one more step on to the end. This can be very useful though, and we're gonna do some word problems to help us see how this is useful. But first, let's just try this between these numbers, which we already have done. So real quick, you've already made your list. See if you can identify the highest common factor. So, factors of 64, we've written these down, right? Factors of 48, we've also written these down. We even found the common factors, right? 1, 2, 4, 8, 16, right? Those are our common factors right here, right? 1, 2, 4, 6, or sorry, 1, 2, 4, 8, and 16. The biggest number in those is 16, right? This step is not too hard. If you've done the other steps, you can easily find this step. Let's try another one. So I'm going to give you a moment, pause the video, find the factors of 102 and 136, and then find the common factors, and then find the highest common factor. Pause the video, take a second, see if you can find the answer. So, factors for 102, we have 1 and 102, right? Easiest one to find. Then we get 2 times 51, right? 3 times 34. 4 and 5 are not possible. Then we get 6 times 17, and that is our last factor pair. So we can move on to 136. We get 1 times 136, 2 times 68, 4 times 34, 8 times 17, and oops, sorry. That is our last factor. You already saw the answer, but if we look at common factors, we have 1, 2, right? Not 4, not 3, not 6, not 8. 17 appears in both lists. 34 appears in both lists, and that is the highest number, right? So our highest common factor is 34, right? As we go through these, you can stop even sooner than finding all the factors. So if we go back here, right? Let's say you found all the factors for 102. You start to find the factors for 136. You find the first factor, 1 times 136. You find the second factor, right? 2 times 68. You can look. Is there a 68 here? No, there is not. And right, this is too big, right? So go to the next factor, 4 times 34. You now have a large common factor, right? And all of the numbers in between here will be smaller than 34, so you don't actually need to find them because this is the biggest factor that they could possibly have in common, right? So you don't actually need to find 8 times 17. So keep that in mind as you do these.